In this class, my name is Harivan Pandey, and in this class, we are going to discuss inheritance, the second part of inheritance, and the aim is to discuss four very important topic which comes under inheritance. The first one is we will discuss multiple inheritance and hierarchical inheritance. At the same time, we'll try to understand the problem which one can come across during writing the program with inheritance and how to resolve the problem. The first problem will be based on the function. Suppose we have written a function in one of in both the parent class, and we want to use in child class, then the compiler get confused during that time in order to access the function. And the second one is ambiguity for the classes. So as far as the learning outcome for this class is concerned, uh, I have listed these five learning outcomes. The first one is defining and understanding the multiple inheritance. So the aim is at the end of this session, you will be in a position to define and understand multiple inheritance, not only theoretically. At the same time, you can write the program using this concept. As I said, we will discuss the issue which one can come across during writing the program. The issue called as ambiguity. And we will discuss how to fix this problem. We will discuss virtual based classes and its importance in inheritance. Virtual based class deals the problem of ambiguity for the classes, whereas the second point where we are talking about the issue with multiple inheritance, here we will use scope resolution operator in order to resolve the ambiguity for the function. The next learning outcome is understanding and implementing hierarchical inheritance. And finally, we will discuss some of the programming example, and we'll analyze those program. So just a quick recap of what we have done in previous session. So here you can see two diagrams. So the first diagram represents the inheritance. So here a single level inheritance. Here we have a class 1 which is a base class, and class 2 which is derived class, and class 2 is using the data member and member function of class 1. And the second diagram shows the different types of inheritance we discussed in the previous classes, such as single level inheritance, multi level inheritance, multiple inheritance, hierarchical, and hybrid. So the focus of this session, as I said, is on multiple inheritance and hierarchical inheritance. We will discuss these inheritance in detail in the coming slides. So the next slide is for multiple inheritance, and this slide, once I will complete this slide, then you will be in a position to define multiple inheritance. So here the first point for the definition of multiple inheritance is given that it is the situation when more than one parent class are inherited by a child class. So here in this diagram, you can see there are two parent class. One is collectible and another one is string. Both these parent class are inherited by this class, which is collectible underscore in string. So the meaning of this diagram is this class, that is this child class, can inherit the property of this collectible class and string class. Now the question which may come in your mind is why we are applying inheritance and what kind of benefit one can achieve after applying this inheritance. So here I have listed some of the benefit of applying multiple inheritance. So it provides a solution where we want to utilize the feature of more than one parent class. So here the first point is saying that where a derived class has attributes of more than one class, because it is easy to form collectible windows and so on. That is, here we have written collectible. So this is a collection of something, and at the same time the child want to use collectible string. So using this type of inheritance, that is multiple inheritance, this type of the feature of collectible as well as string can be utilized with the in child class. It supports varieties of application. So using a single class, we can achieve the feature of two classes, and mm, the important thing is this type of feature is not given with single inheritance and multi-level inheritance, because in case of single level inheritance, this diagram depicts the example of single level inheritance. So here in case of single level inheritance, as we discussed earlier in earlier classes also, there will be only one class and one parent class and one child class. One the this child class 2 can be can utilize the attribute and operation of only one parent class, but multiple inheritance provide the facility of utilizing the attribute and operation of more than one base class. So this is one of the important feature of multiple inheritance. This type of feature cannot be achieved by single inheritance and multi level inheritance. So here I have given one example, and we will implement this example, but before the implementation I want you to just see what we want to do. So the problem is saying that we are interested in computing the power of a number. So suppose a number 5 is given, so we are interested in finding 5 to the power 2, that is 25. So in order to develop such program, we have taken two base classes. First one is base, second one is exponent. We have taken attribute BA of protected type, which is of integer type. The data type is integer type, and with two operation. First one is input underscore base, return type is void. Second one is show underscore base, return type is void. The purpose of these two function is, first one will is given to accept the value for the base, and second one will show the value which we have taken. Similar to this, in exponent class we have taken a variable exp of protected type. The data type for exp is int, and again we have taken two operation. First one is input underscore exp, which is of return type for this function is void, that is null. Second one is show underscore exp, return type is again null. These two function is declared and defined in public section. This plus indicates public. Same here, the purpose of these two function is, first one will accept the value for exponent and second one will show whatever value we will accept. Now the third class is the child class power, and here we have taken PO as a variable. This is given in private section of this class, and we are using input and show. So this function will use the function input bay underscore base and input underscore exp, which is declared in the parent class base and exponent, and show will display the value of the power. So the first class is written in C++ as class base. So here you can see the name of the class is base. In protected section there is a variable BA. In protected section there is a variable BA of integer type. So here integer type variable BA. In the public section of this class we have taken two function input underscore base of return type is void, and show underscore base return type is again void. So input underscore base return type is void, it will accept a value for BA, and similarly show underscore base, it will display the value of BA. Similar to that, we have written a class for exponent. Exponent is the name of the class. Here you can see with data member exp. So here integer type data member exp written in protected section. You can see here protected section. Then there are two function given in public section, input underscore exp. This function will accept the value for exp, and the second function show underscore exp will display the value of the value of exp. And finally, we have written a power class which is inheriting both the parent class base and exponent using public mode. So here class, new class name, colon, visibility modifier, first base class, comma, second base class, and PO is written in private section. So by default, it is private of integer type. We have taken two function input and show in this class power. First one is this. It is what we are doing. We are calling the input underscore base written in a base class over here, and this input underscore exp written in exponent class over here. As soon as this function will get called, immediately the statement given in the body of these function will get executed. So we will get the value of base and exponent, and what we are doing in this function, we are accessing we are accessing the function show underscore base and show underscore exp, and here over here we are calculating the power. And in the main function we are simply declaring the object of power class. So over is the object of power class, and using this object we are accessing input and show operation, which is given here and here. And for the output, if the base is 5, exponent is 3, then we will get 5 to the power 3, that is 25, 125. We have taken another example in order to introduce the problem which a programmer may come across during the implementation of multiple inheritance. The problem is, suppose we have two classes A and B where the function show is given, and we want to access these two function in class C, which is the child class for A and B. Then in such situation compiler get confused which show method class C want to access or want to call, the show for from A or the show from B. So this is a problem. So here I have given a method by which we can resolve. So in order to resolve the problem which we discussed with the function, this type of problem called as ambiguity, where compiler get confused which function compiler derived class want to use. So the way how we can access the function in class A is given here. So what we can do, class C can access show of class A using A scope resolution operator show. So this will indicates or tells to the compiler that this show belongs to class A, or if we are interested in accessing the show method of class B, then we will use in the same way, only the class name will get changed, that is B scope resolution operator show. And inside the main, how we will do, we will simply declare the object of class C, that is the derived class. This class C is a derived class, and O1 dot A show. So this line indicates that we are interested in accessing the method show given in class A, and similarly for class B. And if we have written a show method in class C also, suppose show is here, and show is here also, then using this method we can access the method given in class C, that is the method show given in class C. So in at the end, what we can say, in order to if we are dealing with multiple inheritance, or we are utilizing the feature of multiple inheritance in writing the program, and we have written some function having the same name in all the classes, that is in both the parent class and in the child class. Then by utilizing the feature of scope resolution operator, we can handle such situation, and we can tell to the compiler that we are interested in accessing the function belongs to which class. Now, after the completion of multiple inheritance, we'll discuss hierarchical inheritance, which is also play a very important role. It maintains the hierarchy of the class, and the idea is if one parent class derives multiple classes, then such type of inheritance called as hierarchical inheritance. You have seen in case of multiple inheritance what we are doing here. Multiple parent class derives a single child class, whereas in case of hierarchical inheritance, one parent class derives many child classes. So you can see here we have a class university, And this class derives two child class. First one is college 1 and second one is college 2. And the data member and member functions are listed for each classes. Here we have for university we have university name of character type. The length of this variable is 40. We have method university, which is given in public section, and college class contains a data member C name. Here again the length is 40 with two data member, two member function. First one is college 1 and second one is show underscore college 1. The return type is void. Both the function is given in public section of the class college 1. Second derived class is college 2. Here C name indicates the name of the college. The length is 50 for this variable. And two member function we have taken in this class. First one is college 2 and second one is show underscore college 2. Of the return type is void. Again we have taken these two method in public visibility modifier of class college 2. Now, if we are going for the implementation of this class, then how we'll write the code in C++. So first of all, the name of the class is university. So here we have listed class university. Since this data member uname is given in protected section, so here protected C character type uname, the length is 40. So here we have already specified the length, and in public section we have declared a constructor. So this operation is nothing but the constructor of this class. So that is the reason we have not specified any return type for this. Even here you can see college 1 is a constructor, college 2 is a constructor. So constructor do not require any return type. So that is the reason we have not listed any return type for these constructor. Whereas show underscore college 1 has a return type void, show underscore college 2 has a return type void. And what this constructor will do, this constructor is simply calling a standard function strcpy, which is used to copy some name in a variable name. So here we have already declared a variable uname. So what we want to do, we want to copy this statement, that is Amity University Noida, into this u underscore u name. Now for college 1, since you can see from the diagram, it is already depicted that college 1 is inheriting inherited from university class. So here college 1 class, new class is college 1 colon public, old class name is university. Here we have written a variable C name, length is 40 of character type in protected section. So u name C name 40, university, C name 50, college 1. We are interested in copying this ASCT Noida into this, and finally we are utilizing this function show underscore college 1 to display the name of the college and affiliated university name. So C name will come from this class, whereas U name will come from university class. So we are interested in using the data member of this old class, that is class university, into this. So we are inheriting uname for class college 1, which is the child class for this university class. Similar to this, for college 2, we are inheriting university class. Here C name is of 50, length is 50. This is the constructor. Again we are utilizing this strcpy, that is the standard function, to copy this abs noida into this variable C name. And what we are interested in, we are again interested in utilizing this data uname, which is declared in the parent class university. And that is why we are saying that college 2 is inheriting the feature of university class, that is the parent class. Now in the main function, what we are doing, we are simply declaring the object of class college 1, that is C1, and object of class object of class college 2, that is C2, and we are accessing both the function, that is show underscore college 1, which is given over here, and show underscore college 2, which is given over here. So as soon as compiler will we will start compiling and executing the program, control will enter in the body of the main function. After getting this C1, control will move to this constructor check this statement, copy this string into this, and after that we have written C1 underscore show underscore college 1. Then control will move here, college name, that is display the C name, and C out affiliated to U name. It will this information will come from this constructor. Similarly for college 2, as soon as control will move to this line, control will search for the constructor, that is this, copies this string ABS Noida into C name, and after that reach to this statement, and after getting this statement it will move to the body of this function, displays the college name and affiliated university name. That is why we are getting this type of output, that is college name ASET Noida. We are getting from this function college name, that is C name ASET Noida, and then MIT University from this statement, and similarly we are getting ABS Noida from this statement, and MIT University using C out affiliated to UNIM. Now we will discuss. So far we completed. Before starting virtual based class, I want you to just recall the concept of multiple inheritance and hierarchical inheritance. Multiple inheritance says that if we have many parent class and we want to derive a single class, then in such situation we will apply multiple inheritance. Multiple inheritance suffers with the problem where we are interested in declaring and defining a same function in all the classes, parent class as well as in child class. Then in such situation compiler get confused which function a programmer want to execute. Then to handle such situation we use scope resolution operator. So what we will do, we will simply use the class name, scope resolution operator name, and the name of the function which we want to access. Then we discussed the hierarchical inheritance. The concept of hierarchical inheritance says that if we have only one parent class and many child class, where we want to utilize the data member and member function given in parent class, then we will use hierarchical inheritance. Now the next topic which we'll discuss is virtual base class. Here this diagram explains that we have a class A which is a base class for the class B and class C, and we are deriving a new class D from class B and class C. So all in all we have two types of inheritance in this diagram. First one is hierarchical inheritance, which is given here, that is class A is only one parent class and there is two child class. Just now we discussed the hierarchical inheritance, only one parent class and more than one child class. Then this type of situation explains the concept of hierarchical inheritance, whereas the bottom section of this diagram explains the concept of multiple inheritance, where we have more than one parent and only one child class. The problem in such situation is, so here we have shown the dummy code for the diagram depicted here. So we have a class A, and class B is inheriting class A. So here class B colon, we are inheriting class A in public mode, and similarly we are inheriting we are deriving class C from class A. That is why we have written class C colon public A, and this class is derived from class B and class C, therefore class D, public C and public B. So here we are applying multiple inheritance, whereas this upper portion indicates the concept of hierarchical inheritance. Now why we use virtual base class? Suppose we have a situation where we want to utilize the data member of written in class A for class C. We have this diagram. Here we have written some of the member function and data member and member function given in class C, and this class D want to utilize or access the data member and member function given in class C. Then in such situation compiler get confused which path a compiler control should follow in order to provide the data member and member function to class D, this path or this path, that is class A B D or class A C or D. So this type of situation can be called as class ambiguity. The previous problem which we dealt with inheritance, multiple inheritance, is again known as, is also known as ambiguity situation, and this type of ambiguity is function ambiguity. Whereas, and to deal with this problem we used scope resolution operator, but if we are dealing with the problem of class ambiguity, then scope resolution operator will not serve any purpose. So in order to handle such situation we use virtual base class. So now this slide will introduce you the problem, and the next slide will introduce you how we can utilize the concept of virtual base class in order to resolve the class ambiguity. So here I have written what I explained just now. So class D want to utilize the feature of class A. So it will, compiler control will get confused which path it should follow. It should be through class B or through class C, and it is, the problem is listed over here. And here I have written clearly that this confuses compiler and it flashes error message. So in order to handle such situation, what we will do, we will use simply virtual keyword before the class name which we want to make virtual. So let me read this, these lines. To resolve this ambiguity when class A is inherited in both class B and class C, it is declared as virtual class by placing the keyword virtual, as class B is inheriting class A and we want to make this class virtual. So what we will do, we will simply place virtual keyword before or after, both are correct. So here I have placed, I have taken both the situation. Class B is inheriting class A under virtual, and making it virtual base class, making this base class as a virtual, whereas class C colon public virtual A. So here I have placed virtual keyword before the visibility modifier, whereas in the second situation I have placed virtual keyword after the visibility modifier. Both are correct, and in the note section of this slide I have written it clearly. Now the advantage of virtual base class is, by using this we can save our space and it avoids ambiguity. As I said, when we deal with such situation like this, it creates class ambiguity situation, and virtual base class provides the facility to deal with or avoid ambiguity, or it elevates situation of ambiguity, especially when we will apply hierarchical and multiple inheritance together, or when we use the concept of hybrid inheritance. And a single, the last point is very important, a single copy of its member is shared by all the base classes that use it as a virtual base class. So since class B and class C, both the classes are sharing class A as a virtual, so the data member and member function which is written in class A can be used in class B as well as in class C as a virtual base class. So this point is very important, because no need to write the data member and member function again. It can be one. We will write the statement only one, and it will be it can be shared again and again. So that is the key benefit of using virtual base class. So all in all, we can say that virtual base class provides two types of benefit. One is it avoids class ambiguity. It provides the facility to save the space. It removes the duplicacy of data in many classes. Now finally the conclusion. So in this session we mainly discussed the two inheritance in detail. First one is multiple inheritance and second one is hierarchical inheritance. In case of multiple inheritance, what we will do, the situation will be like we have multiple parent classes or base classes, and we want to derive only one child class. So such type of inheritance can be called as multiple inheritance. This feature is very important. C++ supports multiple inheritance. Java do not support multiple inheritance. So in place of multiple inheritance, Java supports the concept of inheritance, which we will discuss in the coming classes in detail. Thereafter, we discussed the concept of hierarchical inheritance. In case of hierarchical inheritance, we will come across the situation where there will be only one parent class and we want to derive multiple child class, and all the child class will utilize the data member and member function given in only one parent class. After that, we discussed the problem which one can come across during writing the program when the programmer is want to utilize the feature of multiple inheritance. The problem is ambiguity. There will be two types of ambiguity. First one is function-based ambiguity. Second one is class-based ambiguity. In case of function-based ambiguity, what will happen? A same function name will be declared in parent, all the parent class as well as in the child class, and it creates confusion in compiler's mind which function programmer want to execute, really want to execute in the main function. So in order to resolve such problem, we discuss the scope resolution operator. We'll simply place scope resolution operator before the name of the function with the class name. It will tell, the statement will tell that to the compiler that specifically we are interested in using this function from this particular class. Secondly, we discussed the virtual base class, and we discussed virtual base class. It resolves the problem of class ambiguity, and in order to achieve the feature of virtual base class, what we will do, we will simply make the base class virtual. That is the reason it is called so, that is virtual base class. So we are what we are doing, we are simply making the base class as a virtual. We can place virtual keyword before the visibility modifier as well as after the visibility modifier. It will not make any effect. It will not affect the execution of the program. And I will recommend you all should follow import. I have already we have already created your ID and password. We have your ID and passwords are registered with import. So in order to retrieve the video lecture, you can visit iucee.imports.com. There you can get the video lecture. You can get assignments, multiple choice question. You can discuss if you have, you can create discussion, and if you have any query related to the lecture, you can post there. I will try to fix it, and as soon as I will see, I will respond you back. If and I will request, I will request you all start working on the assignment, and I have given assignment based on this lecture, and hopefully you will enjoy. Thank you very much.